Everyone, we are continuing with day 17, just of day 16 part 2, which was quite challenging as you might expect, and I expect the upcoming task to be even harder for the people that join us for the first time. We are doing Advent of Code 2021 and we're using Go as our target language. We're keeping few things as for example here we have our main Go file. We read always the input from a file, store it in the given folder. We have some test input simply to test things, and we have our prompt markdown file in which we save all the input that we gave to GPT-4, Bing, etc. And we have always the answers with the full text and so on to be able to compare in the future if we decide to evaluate a new model to see how it was doing on these tasks. And as you can see here, already we were getting short on the output, and the codes were cut, although on a part that we were able to write ourselves relatively easy. Let's see how we'll go with day 17. Again, for a little background, I'm not a professional Go developer, but I've been doing Advent of Code in Go myself 2020 and 2022, and I get 2020 to day 10 including, and 2022 to day 13 also solved, and which means that I have understanding of Go. I can debug it to some degree, and I'm familiar with the syntax. However, I'm not working professionally on it and not very familiar with the concurrency model or things like that. But for this given task, we haven't encountered anything like that will require really such a knowledge. Firstly, let's copy day 16 part 1. We want to use it as a template for our daily task. What's happened with that? Want it here. We have name 17 part 1, and in that case we have no input, we have no program, and we have no test input. For our prompt, let's keep our main input. We always start and saying you are a prominent competitive programmer. You have been invited to participate in a programming competition. You are given a task to solve. Write a Golang program that solves the task and read the input from a test file, because usually we need to debug the program. And here we simply give the GPT-4 the text from here. However, because the task after day 10 seems to get very complicated, it's clear that the algorithm so far for the last 2-3 days always had some subtle errors, and we needed to go through the code and correct some of them, although 95% of the code was written very well, and in some places I needed myself to search in Bing to Bing it to see what certain parts of the code are doing, etc. And yeah, for that purpose we firstly go through the problem, get some mental picture of what's expected from us, how eventually the final program should work, and after that we continue with GPT-4 in the case. You finally decode the health message. Hi, the message says. You continue searching for the sled keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You would better send a probe to investigate. Okay. The probe launcher on your submarine can fire a probe with any integer velocity in the x forward and y upward, which we can go forward and up and downward on the y-axis, and downward is marked with y-axis negative number. Okay, we're going to fire our probe using some integers to denote the velocity of the probe on two-dimensional plane in this case. For example, an initial xy velocity like 0, 10 would fire the probe straight up, because we're 10 we're going down. If it's minus 10 we'll be down, and 0 we're not moving horizontally. If it's 5, 5 will be like a 45-degree angle. If it's 5 minus 5 will be like that, etc. Okay, that's quite clear. Would fire the probe straight up, while initial velocity like a 10 minus 1 will fire it probe forward and slightly down, like that. The probe starts at 0, 0, then it will follow some trajectory by moving in steps. We have these discrete steps, nothing continuous. On each step, these changes occur in the following order. Okay, we have the probe's x position increased by its x velocity, that makes sense, and the probe y position increasing by its velocity. Due to drag, the probe x velocity changed by 1 toward the value 0. That is, it decreases by 1 if it is greater than 0, increases by 1 if it is less than 0, and or does not change if it is already 0. Okay, if it's positive, we're getting, for example, from 10 it's getting to 9, 8, and so on. If it's minus 5, will be minus 4, minus 3, minus 2, minus 1, up to 0. And when it gets to 0, it stops changing. Due to gravity, the probe velocity decreased by 1. For the prop to successfully make it into the trench, the prop must be on some trajectory that causes it to be within target area after any step. By submarine computer has already calculated the trajectory area your puzzle input. For example, your target area is 20 to 30 and minus 10 to minus 5. This target area means that you need to find initial xy velocity values such that after any steps the prop's position is at least 20, at most 30, and the prop y position is at least minus 10 and at most minus 5, which means that these intervals are inclusive. Even the trajectory area, one initial velocity that caused the prop to be within the target area after any step is. Okay, I think that we're, at least that part seems relatively clear. Let me go here and think a little bit if there's another one thing that I want to show before to paste that, because we already, as I said the previous time, we have severe problems with GPT-4. It's here when we go to the token input. It's relatively, this one with the start and so on are taking a lot of space. In this case doesn't seem so big, but yeah, they might be. Let me go again to that and simply complete the whole description if there are some caveats, because here given that we're choosing initial velocity that is 7 on the x moving forward and 2 moving upward, and our final position in this diagram, S is the prop's initial position 0, 0. The x coordinates increase to the right and the y coordinate increase upwards. Okay. In this bottom right position that are within the target area are shown as t after each step. Until the target array is reached, the position in the prop is marked with the bottom right is both a position the prop reaches and position in the target area. Okay, it's up here. Another initial velocity that causes the prop to be within the target area after is 6.3, and here it's up here. Another one is 9.0. Okay, we can shoot a lot of times, but sometimes in one initial velocity that doesn't cause the prop to be within the target area after any step is. Okay, let me get rid of this one because it's more visual thing. Not sure that will bring anything to me. I simply will cut on the tokens that we can use. Put here dot, that's fine. The prop appears to pass through the target area. And that's absolutely fine. What's our target? Instead of continuing down to the right, only the first few steps are shown. if you're going to fire highly scientific prop out of super cool prop launcher, you might as well do it with style. How high can you make the prop go while still reach the target area? In the above example, using initial velocity of 6.9 is the best way to cause the prop to reach the maximum Y position of 45. Any higher initial velocity causes the prop to overshoot the target area entirely. Finding the initial velocity that caused the prop to reach the highest Y position and still evaluate it within the target area after any step, what is the highest Y position it reached on this trajectory. Okay, that's very interesting, and here we can see the target area. Very interesting challenge. Let's see how our program will do. Let me firstly close some previous input that we don't need anymore. Let me, where was this example? Oh, and this is the example, the test input. In this case, with this test input, the algorithm should return us this the maximal position should be 45. Okay, extremely interesting task. We're having our prompt. I will still keep part of the input. I delete one part because it was taking too many tokens. As you can see, was 1000 something. Now we're significantly less, but if we hit some problems with GPT-4, I will get rid of all the visual inputs. Now we're having step-by-step breakdown what we need to do. First, let's break down the problem and create an algorithm to solve it. We have one that it's reading the file, that's perfectly fine. We need to iterate going through x and y things. For each combination of velocity, simulate the prop trajectory. Okay, that sounds very reasonable. Check if the prop position is within the target area during any step of the trajectory. If the prop reaches the target area, track the maximum Y position reached. Find the maximal Y position across all valid trajectories. Okay. Now we're reading the ranges. That part is so to say not so interesting. My main worry is that so far today, because it's a working day, I think GPT-4 is overloaded with requests. People are writing books with it, programming at work and so on. We might actually hit the possible limit. Okay, let's see. Now we're whooping. We're having our max y and we're trying to find something that is bigger than that. I think with this algorithm it's a little bit not super easy with it, because it's going probably once we after a given value, when we are too out of scope, after that we simply will see that we'll never reach our target, and we'll be whooping, so to say, halfly meaningless. But let's give a try. We have the velocity and so on. All this stuff looks more or less legit. We had some network failure, but this fell after the program was finished. Yeah, you're kind of lucky. OpenAI are improving on their web servers. I only can imagine how costly it is to run this model. But anyway, let's see the current implementation. There are potentially some problems. I can see that we need to firstly focus on the parsing the input. After we verify that parsing input are correct, we should verify that the hash velocity is exactly what we would expect, and all this stuff. For the moment, let me get here, let me not give, alright, let's copy in the network error if someone is checking to know that there was a network error. Okay, here we're with the test file, etc. Let's see if we can read it. We're going through this thousands of iterations, which yeah, I'm not the biggest fan of this idea. Here we know that it's much smaller. Let's make our life a little bit easier. And see if it's actually completing or not. Might turn out that what was our expected result? Initial velocity is 6.9 and we're getting to 45. Okay, let me see with something that is 10 by 10 if we'll complete in some reasonable amount of time, because I'm not sure that the problem is here. It might be something wrong with how we are breaking the values, because here we have some for loop. 1 second, when on earth we are breaking this for loop? Because here it's like infinite for loop. Okay, let's start step by step. We need to firstly get here and see our parts are correct. Print line, we have parts. What are our parts? We have of this one, this one, this one, etc. Okay, let's see if the range X and range Y are correctly parsed. The range Y seems correct, but the range X not really. And why is that? Because here we're cutting 2, but here actually we don't want to cut only 2. We want to cut the length of this one. What is the length of this string? I mean, I think that's a bit abuse. We shouldn't use that for that. Okay, that's very nice that we couldn't do it in this way. Let me do it with elixir string length. We shouldn't 13, and here we should simply have 15. Let me check now. Okay, we have 20 and 30. Okay, that's legit. And let me see what is X. X max and Y max. If everything is parsed as expected. Okay, let me stop this one. Yeah, we have 20, 30, min, max, and so on. Exactly. Minimum is -10, the maximum is -5. Absolutely brilliant. Okay, here let me see what's happening with this print X and Y values. Okay, let me stop this one. Okay, we start with -10 and -10, and we simply never leave one second, sorry about that. We never leave this internal loop. Okay, we can see that the problem is here in the internal loop. I will keep that with -10 and 10 or 2 loop. We're crazy. Let's see what's going on in this loop, because here we are trying, like the initial position, we're starting with this one and this one, and we're breaking only if this check becomes this check, we're stopping 1 second. We're stopping when we are in the array because the current position is bigger than the minimum x. It's also smaller. It is okay. We're checking that the current position is inside the box, and if we are there, we're simply breaking, which is absolutely fine, but we need to have in one condition that we are actually breaking also if we are so to say miss completely the box, because if we don't go in the direction of the box, whenever is the box, we will not get anywhere. What is this? That's the velocity with which we start, and we here change this velocity. Okay, that's perfectly fine. And in our case, we know that we always move forward in the x direction. If we are x position, we couldn't move negative, and this our velocity could it be only positive? Yeah, our velocity from x can be only positive, so to say. We couldn't do minus 10, is that correct? Yeah, we can start with x0, but our x velocity can be only positive. We can start from under and go like that, but we couldn't go shoot in the opposite direction. Okay, and this means if our x position is more than the max, we should brake. There is not much that we can do really. Okay, again, I can see here, because we have this negative thing, we couldn't, there is no such thing, that negative part. It is not fine. Also, if we have it 0, that means we'll go we also should break if our we get further away for the box. For the x, we know that if our we, so to say, surpass the box, for example here it's where it's ending the x coordinate, if we are going in this direction we should simply stop, because we couldn't end we cannot enter the box. But we also, if we see that the distance between us here and the distance between this box it's not changing. Let me do it for the y. I think that for the x we want to have also delta. For the y, if the y position is under the box, yeah, we can change it. We need to have something like a y delta. Delta y and delta x. What we need to do is we have the change in the position, and we also need to stop if we see what we need to measure is whenever we go far away from that and we notice that we simply get further and further away from our target, we need to stop and to do that let me ask a little bit Bing for this with a prompt. I have prompt to Bing. I have go program that simulate throwing a rock to a target area. My program simulate the rock trajectory how could I know that my rock missed the target and is going further away? I want to have check for that my target has actually it's XY coordinates as integers, and my position is as well of integers. The velocity is as well integer. How could I determine that my rock and will not hit it? Could you write me small function for that track in going? Okay, let's give a shout to Bing and see how well is Bing performing. That was what we were asking the previous day. Is moving away. Okay, we're checking the velocity and we're checking where it's going. Okay, it's doing all of this check. Let me do that answer. Really, I'm not absolutely sure for here because our we have this changing of the velocity. However, I think still would it work with. But let's add this function that's actually saying, okay, this inner loop is actually completely meaningless. to run it further. Let me do it here where I was checking for that. We have exactly this x, y, velocity, min, max values. Okay. And if that's true, I simply should break. If the position is under the minimum and the velocity in x is less than 0, okay, true, which means that now I shouldn't get to such a thing, but yeah, I mean, if it's above the max and my velocity is in this direction, I will miss it. If I'm under with y and my velocity is as well negative, true if my y position is better than y max and my velocity is also 0. I think in this case, because of my I think I need to remove this because of the effect of gravity. Here was stopping even when I was here, simply ignoring this effect of gravity that actually will change my direction. I think that I don't need this. For the y position, if I'm here and going under, the gravity will push me down, and on x-axis the drag has effect, but not the gravity. Okay, that looks fine. Let me run it with this initial one. Okay, the same thing, and let's try with our input. The real big deal. 8646. And that's day 17, part 1. Hope that was useful for you, and hope to see you in part 2. Have a nice one. Bye.